Okay, this is the video for 7-1, which for pirates is Dominican Republic or Haiti. For Route 66, it's Amarillo or Cherokee County. What the students are going to be doing here is figuring out the area of a circle using a paper plate. So they'll get a paper plate, they'll fold it in half. The purpose of this is to show, to demonstrate this is the diameter of this circle. They'll fold it again. All right, so now we have a diameter, but we also have a radius. So what they're going to do now, using a ruler, they're going to draw a whole bunch of lines, a whole bunch of diameters on their paper plate. I'm going to draw a whole bunch more here in a minute, but they should end up with at least 16. So we want as many diameters on here as possible, and you'll see why in just a minute. Okay, so you can see I have a bunch of diameters on here. What the students are going to do now is cut their paper plate in half along one of their folds, because that's probably one of the better diameters that they just created. Then they're going to cut on each of these radii lines, and they're going to cut almost all the way out to, they're not going to cut completely through. So as far as they can go, if they happen to cut all the way through it, it's not a big deal, and you'll see why in just a minute. You can pause it again. Okay, on your table, you will have contact paper with the sticky side up. Hopefully it will be stuck down a little bit just to keep it from moving. So this is for as the students, after they've cut their paper plates, you can see I cut a whole bunch of mine here, and you'll see this is super helpful. Basically, we're making a rectangle out of a circle. So this contact paper helps to hold stuff, which is why I said if they cut through one of their edges, it's not a big deal, and you'll see why here in just a sec, because I cut through one of my edges. So what you're going to end up doing, what the students are going to end up doing, and I won't do this the whole way because you probably get the idea by now, but they're going to fit. They'll be able to fit together better than I did, but they'll fit together their circle. So ultimately, this will help them to understand why the circumference of the circle times the radius of the circle equals the surface area of the circle, because this is half of the circumference, this is the other half of the circumference, these are the two radii of the circle. The way that we know that the surface area of a circle is pi r squared. Thinking back to our rectangle that we made with the paper plate, it's easy to solve the area of a rectangle because it's length times width. In this particular case, the width of our paper plate ends up being the radius, or the width of our paper plate rectangle is the radius. So now we need to figure out, why does this correlate? What's the deal with the length? Well, the length is half of the circumference, and we know that because we cut the paper plate in half, right? And half of our rectangle length is this, and the other half of our rectangle length is that. So we will learn that the students will learn from station 7-3 that the ratio between the circumference and the diameter is pi. So then if we rearrange this formula, that pi equals circumference divided by diameter, if we rearrange that formula, we get the circumference equals 2r pi. So half of that circumference, remember, because that's this up here, is our length. So ultimately, what we're looking at is the area of our rectangle is it's going to be width times length. We know that the width is the radius, and we know that the length is going to be 1/2 of 2r pi. I don't know why I wrote that. The length is 1/2 of 2r pi. So when you do that, your length is r times pi. Your width is r. So your width times your length is r times pi, which is pi r squared.